Okay, we should be live. I didn't announce this, so there's no one here, but I just wanted to continue where we left off last time, which was we're making these wide strings, and I was saying something really stupid, which was, oh, it's weird that the strings, after you make them wide, converting them from a normal string into these wide versions, they've got these 0 bytes in between. And it's not weird at all if you think about that our machines are little endian, so we're actually reading 2 bytes at a time, right? And then this would be the first byte. Actually, no, it wouldn't. This would still be the first byte. But anyway, regardless, it makes total sense that these are wide like that. So where were we up to? We got the ability to create a file, which you can see here with the weird Unicode in there, so that's all working perfectly fine. And we were going to do something. We were going to wrap it. So here we go. So we're going to wrap reading a file and writing a file. So we're going to read a file based on a path that we pass in using our own custom type, which is this string type here. There we go. And we're going to write it to an allocator, which could be any kind of allocator. My go-to definition is not working, but the allocator type looks like this. And at the moment we've just got arenas and pools, so we're going to use an arena for sure. Well, not for sure, but most likely, because you wouldn't want to read a string into a pool. It doesn't really make sense. So if we go back here, you can see we've created our random file, and I don't think we've written anything into it. So if we have a look, there's actually no data in here. So why don't we add some stuff? Alright. Hang on, I just gotta move this YouTube thing. It's distracting. There we go. Alright. So, I've added some data to our file, this one. Now we should be able to read this, which means if we come in here, we've created a file, we need to actually read the file. So read the file based on the handle, pass in a pointer to, I believe this is the destination buffer. So for now, we'll just make a quick place to put this. Okay, number of bytes to read. Well, that's a bit strange. Let's have a look. I guess we have to do some kind of query on the file to know how big it is. So this is... okay. So it's asynchronous. Interesting. Probably don't want that. Then we'll just use read file. Number of bytes to read, the maximum number of bytes to be read. Okay, so for now we can just set that to the size of the buffer. And this will be where we put the number of bytes that were read. So put the length, I guess, or bytes, and we'll put a number here, so usize bytes, and overlapped. What is this? Okay, pointer to an overlapped structure. Oh yes, I remember this. I've done this once before. So this is weird but basically you just need to make this struct called overlapped, and I think you can just pass it in as is. So overlapped, and I'll just put all zeros in there to make sure there's nothing weird going on. Pass that in. What's the problem with this? Okay. Oh, so this can only be a 32-bit number returned, which means we might not be able to open really big files, which is a bit of a problem. What's the problem with this? Oh, it has to be signed. Am I reading this incorrectly? LPD word, aka unsigned long pointer. Oh, it's, yeah, unsigned. Long is a 32-bit. Is it just complaining because... Let's see. Where is this? What is this? Okay. So it's a far D word. Far D word. Okay. What does that mean? Well, let's look at the documentation. The parameter can be null. I think it might be useful for it not to be null. Okay, we'll test it with null first. Okay, what do we get out of this? We get a boolean. Alright. Is it success or is it failure? What's the return type? Here we go. The return value is non-zero. True. Okay. Okay. All good. Well, let's have a look at that, shall we? What did we get back? We got a 0, so that failed, apparently. And if we look at destination, there's nothing in there. Yep. Okay. What did we do wrong? So our file handle is this. Did I save this? I did. Yep. Okay, file handle is this. Destination buffer. Fine. I think. Number of bytes to read, maximum 512. Okay, and then the number of bytes actually read. And one of these. Okay, let me read the overlap documentation again. A valid and unique overlapped structure. Okay. Yeah, I'm pretty sure we don't have to set any of these things ourselves. If I remember, there's, here we go, open a file for reading or writing. Open a file for writing. Create file. That's all done. There we go, read file. So we've got the handle here. We've got a buffer to read into, which is this one, buffer size. And that should be fine. And buffer size -1, okay, fair enough. overlapped. Yeah, exactly the same. And then file IO completion routine. What is that? Oh, okay. That might be handy. Let's grab this. Just put it here temporarily. I can't print things though. But we can do a debug break. Where are we going to? Over there. No. Hang on, the parameters are different here. Oh, this is ReadFile EX. Okay. Right. What was it called? Handle, buffer, bytes to read. Yeah. Alright, let's try this. What did we get? Success is 0. Alright. Didn't go into this procedure, did we? Maybe I'll... Maybe there's not enough stuff happening in here. So we can say... Maybe if I make this global, I just don't want it to get skipped, although it won't because we're using debug, so it shouldn't be removed at all, but it's all fine. Okay. Alright, well that's not great. So we never go into this procedure, and we don't get any data. What we should check, I guess, are the parameters. So, we're reading this file handle, which is invalid. Okay. I'm pretty sure that's an invalid file handle. -1, essentially. So, what's the problem with create file? It was working yesterday. Ah, that's why. So, create new, we need to replace this. So if we go to, what was it called? Create file, W. Right, so if we look at the mode, where is it? Here we go. Create new. Creates a new file only if it doesn't exist. If the specified file exists, the function fails. Oh, that's not great. So we probably want open existing, since we already have the file open now. Created now, rather. Okay, let's have a look. Did we get a file handle? Yes. Did we get data? Yes, we did. And what did our data look like? Well, it looks like that. That's great. That's what we wanted. Perfect. Okay. So, we can create files, we can read files. Creating file is this, but can we write files? So let's do that next. So if I look at create file again, file share read. No process can open the file device if it requests read access. Right. That's fine. We're just going to disable file sharing for now. What am I looking for? There is a way to write files. Write file ex. Okay, so I've got the handle and a buffer to the data that we're going to write, the number of bytes to write, and an overlapped structure, and an overlapped completion routine. Okay, great. The handle must have generic write access. So we've got generic read and generic write access. That's good. Okay. We'll just put a little... Actually, I'll just make this write success. Alright, so we've got our handle. So we're going to write different data into here. Actually, I'll make it just a character pointer so I can just write whatever. This is some different data. Okay, and the number of bytes is going to be... I think we can do size of... Is that right? Oh, it'll only work on the literal. In which case, you know what, I'll just make this a string to be sure. Then we can just write some data.data and some data.length. Overlapped, so we need another overlapped structure. And the completion routine, I guess we'll just use the same one. What's the problem here? OL2. Oh, I didn't make it a pointer. Very good. There we go. Once we can verify all this stuff is working. Was that a success? It was, apparently. So let's have a look at our file. That does not look like success. But maybe if I reload it. It's being used by another process. Oh, we haven't closed it yet. Okay. Close the handle. Hey, would you look at that? That's not really what we wanted though. There's all this other data in here still. Or is that just my editor? Nope. Okay. Interesting. Huh. That sounds a bit strange. So if you write into a file, you don't override the data that's... I mean, you override only the part that you wrote in at the beginning, and then the rest is just intact. That's a bit weird. Wouldn't have expected that. It's kind of interesting, though. You could probably use that for some good things, like overriding, I don't know, the header or something of a file without changing the data. To write to the end of the file, specify both the offset and offset high members of the overlap structure as 0xFFFFFF. Yeah, okay. So that's what we should have read. Offset and offset high. Alright. Well, let's have a look, shall we? So, run through this again. Close the handle. Reload this. Oops. Reload. Oh, that's... Huh. It's appending. Is that right? Oh, that's what this means. To append. Not to override all of the data. That makes sense. Right, so it's the byte offsetter, which is start writing to the file. Okay. Okay, so that's cool. We figured out how to append things. Okay. So what would be the best thing to do in this situation? You could delete the file, create it again, and then write it. That would probably work, right? Is there a delete file? There is. What does it do? Okay, that's not really useful. Okay, just delete file and then a boolean. I wonder if its success is 0 or 1. Let's see, shall we? Okay, so before we read, actually before we create, but that's only open existing. So what we do here is we change this to, what was it called again? It was like already exists, open only, can't remember all these things. Right, create new, we could just use create always. That would override the file. Let's try that. Oh, what did I just do? Just wrote it on 2 lines. Alright. So we should create a new file. Let's see, did that work? File handle is, yep. And read the file into this buffer, which will probably be nothing because it's new. Well, it should be nothing, yep, that's correct. Now we're going to write some data to the end of the file, but this could actually just be 0. Okay, and then, was this a success? Yes, apparently. So let's have a look at our file. Reload, yeah, there we go. Okay, that's, I think, more what you would want in the normal case, where you actually override the file, depending on what you're doing, I guess. So, great. So hopefully that is all understandable, and now we can actually make some kind of functionality that makes sense for us. So when we read a file, we only want to read a file that actually exists. So we don't want this to be create always. We want this to be open existing. And this wide string, let's say we've got, I don't know, 512 is our maximum path length, just to get us going. And we need to put in a string here. What's the problem? It's not constant, alright. Is that better? So we convert our string pt2 wide string, open a file, and if fh probably put the result here. Result.data equals, well, we need to read the file into the result data. Okay. So we're going to grab this. We need to get the length of the file as well. Surely there's a way to query that. File info or something. Get file information by handle. That sounds good. Okay, and this returns us a file information. For a more basic version for desktop applications. Okay, sure. For a more advanced version. Okay, we'll just use the basic version. What do we get? Okay, file size high, file size low. That's probably what we need. So that's interesting. So we can get 64-bit file sizes, but then when we use that read, this takes only 32-bit. Not great, but that's alright. File info by handle class. Okay. And a file information. Long pointer to file information. What is that? Ah. Okay. I'm going to use the other one. Hang on a second. Right. So... no. Pointer to by handle. I was just looking at this. Oh, that's what it's actually called. By handle file information. Okay. Okay, there we go. I'm going to just nil that out here. We're going to allocate space based on the file information we get back. So we'll just use the file size low bits for now. Well, I guess I don't need to say it's a U32, it's already typed right there. Alright guys, looks like this is almost ready. So I'll put a break here. think that looks good. Okay, so we need to make a path. What are we going to read? Let's just read my file. I guess this one. It's a bit hard to use those kind of strings where the bytes are all messed up. Is that correct? I think so. And we'll put this in the permanent allocator. Alright. Let's have a look, shall we? It's still running, so I can't compile. There we go. Alright. I think my daughter's waking up soon. So we got a success, apparently. And let's have a look at our result data. This is some different data. That's correct. Wow. Did we just get it on the first try? That never happens. 27. Yeah, that's great. So if we look here, awesome. Okay, we now have a wrapped Windows 32 layer, Windows layer, I guess, function called file read. That's great. It only supports up to 4 GB files, but that's fine for now. Goes into this allocator. Alright, that's good. I'm happy with that. Let's delete a lot of this commented stuff. Alright, so I've got a string builder, a file reading. Next, we need to put file writing in there. Hey Oscar. Oscar asks if I'm using Comic Sans. It's close. It's called Comic Mono. So yeah, it's based on Comic Sans. So now what we want is something like, we've got this string that we built, something 1 2 3 4 with this number. We want to be able to do file write. I guess we would just put in a string, because at the end of the day that can handle all binary data, right? So basically this. And a path. So the path would be output I think that looks good. Probably want to return success or failure. Yeah, that sounds pretty good. Looks good to me. I'm going to say by default the result is false, that we failed. And then we're going to do all the things we need to do. So, to do support longer paths. And here we're going to support 64-bit sizes. I'm going to do basically the same thing, so we'll just grab this. And instead of open existing, I guess we should say, what was it, open always? I should just leave this page open. Not create file A, create file W. Yeah. Create always. Creates a new file always. If it exists and is writable, the function truncates the file. Yeah. I guess that's what we should do. But I guess that means if it fails, it does destroy the file. I'll put a note. Great. If we got a file handle... Wait, that's not correct. If file handle is not equal to... I think that's right. Oh, it's a pointer. Oh, that's fine. I'm pretty sure that's right. Let's have a look. Return type. So return value is going to be invalid handle value. Great. What is that? I know that it's 0xFFFFFF, but I guess I should write that instead. Invalid handle value. It is a long pointer -1. Okay. So this is a void pointer? Because a handle is a void pointer. Great. Okay, so we're doing basically the same thing here. We don't need the file information. We just need to write the file. Oh yeah, I didn't do anything with the success. Okay, so we're going to write the file, and it's going to be this file handle, and this is the buffer. So that would be data.data. Oh, I don't like that. I hate whenever you have data.data. Data.length. Overlapped and nil. That's fine. That's all good. Hello, experimentators. How you doing? Sorry if I know you by a different name. Oh, yeah, hey, how you doing, Josh? Alright, so we just finished wrapping a Win32 file read function. Now we're making a file write function. Pretty thrilling stuff. I should also put the to-do in the other function in case I forget. We want to support longer paths. So we're going to write a file. We need to close the file handle. I don't think I did that. No, I didn't. So we need to close handle, because that's how it works. You don't close the file, close the handle. Okay. What am I missing? I don't know if I am missing anything. Let's see. Okay, we're going to try to write a file called output.txt, and we're going to write basically this string that we built here. Let's give it a go. So we read a file. Okay, we just wrote a file apparently. And we're going to close the handle. And hey, that's correct. I think. I need to look at it in the debugger. Yeah, that's right. It looks a bit weird looking at, that's a U32 number here. XV4 and then like some random character, but that's all correct. That's good. Alright, so we've wrapped file reading and file writing. That's awesome. Probably want to remove the debug breaks. We need to do something with success. Like, I don't know, maybe put it here. Make it false. Make it true. If false, then I don't have to do anything actually. I don't have to do anything with success because the data and the length will be 0 if it fails, so we don't even need that. Same with this, actually, nope, not same with this. Result, there we go. That makes sense. Cool. I need to make a list of things that I want to make because I keep forgetting. Got stream brain. Actually, I do have a list here. Memory allocators, string handling, file I/O. So we kind of just finished that. Containers. Well, that's very vague. I didn't write what kind of containers, but I think a queue would be cool to make. Is there anything else I need to do for file writing? File reading? Kind of want to extend the string builder a little bit, but it's not very interesting. What's your problem? Undeclared library function memcopy. That's fine. We don't need to declare that. Right? Did I declare it somewhere? No, I didn't. I'll just declare it in... I guess I'll do it in... yeah, types. Doesn't really make sense, but... memcopy, and it's void pointer int unsigned. Well, yeah, I think that's correct. Great, that error goes away. I'd like to write my own memcopy, but it seems kind of pointless since the compiler has it as an intrinsic. Conflicting types. Is it actually? Oh. This is incorrect apparently. Okay. What is memcopy? You copy to a destination from a source. Yeah. All right. Sorry, I just got a phone call. 1 second. Okay, probably gonna have to wrap it up shortly anyway. Configure Vim and Emac macros. Emacs. Why am I saying Emac? You wrote Emac, okay. What are we doing? Sorry, distractions always throw me for a loop here. Great. Yeah, that's good. I think I'm gonna probably leave it there actually, because my daughter's waking up. I think. Yeah, she's still asleep. She keeps making noises. What shall we do? What shall we do? Do you have any ideas, Josh? I accomplished what I was going to. So that was all kind of good. Not really? Okay, that's alright. It's not your job to come up with my stream ideas. I am going to delete this. Nobody wants this. Nobody wants that either. What's the problem now? How is that a conflicting type for memcopy? Is there something wrong with this? I don't think so. Or does it return a pointer? I need to look up memcopy. Oh god, I hate this website. Yeah, it returns a pointer. Okay. And it's got a constant void as the... Oh, there we go. You're gonna stop complaining now? That would be great. Okay. Great. Well, I guess we'll just move on to building something else. What I actually wanted to build with all of this string stuff was a file format. So I was thinking, but maybe I want to do that in a dedicated stream. So I'm going to call this here. I might do that tonight if I have some time. And yeah, thanks for tuning in. I'm not looking at the camera. There we go. Thanks for tuning in. And I'll see you guys next time.